Right now, the universe is laughing at us. Seriously. Here we are, thinking our problems are huge, our cities are impressive, and our solar system is somehow significant, while the cosmos stretches out in every direction, vast, incomprehensible, and entirely indifferent. Galaxies the size of our imagination spin billions of light years away, stars burn with patience we can't fathom, and black holes lurk quietly, waiting to remind us that scale is a cosmic joke we barely understand. The first shocking realization: the universe isn't just big, it's absurdly, terrifyingly, mind-bendingly big. And it doesn't care if we grasp it, name it, or even exist at all. To get a sense of scale, let's start close to home, relatively speaking. The Sun, a perfectly average star by most standards, is already enormous. You could line up roughly 1 million Earths inside it. But that's just the appetizer. Our solar system stretches billions of miles from the Sun to the outermost edges of the Oort cloud, where icy comets drift like cosmic tumbleweeds. And yet, that entire neighborhood is just one tiny dot in the Milky Way galaxy, which contains somewhere between 100 and 400 billion stars. Try picturing that: 100 billion suns, each potentially hosting its own solar system, each system potentially hosting planets, moons, maybe life. It's enough to make the most meticulous planner or obsessive spreadsheet nerd throw up their hands. And it's hilarious, in a humbling way, that we still argue about traffic on Earth while ignoring the galactic scale of things. The Milky Way, vast as it is just one galaxy among an estimated 2 trillion galaxies in the observable universe. 2 trillion. Let that number roll around in your head. Our entire solar system, with all its planets, moons, and comets, is a speck inside a star that is a speck inside a galaxy, which itself is a speck among trillions of galaxies. Each galaxy contains billions of stars. Some galaxies are small and faint. Others are massive, sprawling structures with hundreds of billions of stars, supermassive black holes at their centers, and gravitational dynamics that stretch the imagination. And yet, all of this is just the observable universe, the slice we can see. Beyond that, well, nobody really knows. The universe could be infinite, or it could curve back on itself in ways that make human comprehension dizzying. The scale is so vast that it actively mocks our intuition. Distances are measured in light years because conventional units fail utterly. A light year, the distance light travels in a year, is nearly 6 trillion miles. Alpha Centauri, our closest stellar neighbor, is 4.2 light years away. That's 25 trillion miles. Voyager 1, humanity's farthest flung spacecraft, has been traveling for over 4 decades and has barely reached the edge of the Sun's influence. It's a slow crawl on the cosmic treadmill, and it makes human impatience look almost charmingly naive. The universe doesn't rush, doesn't wait, and certainly doesn't care if our travel plans take decades, centuries, or millennia. And yet, humans can't help but try to quantify it, visualize it, and even joke about it. We draw scale models, charts, and animations to give us a sense of cosmic distances. We compare galaxies to cities, clusters to continents, and the universe itself to a sandbox so large we can't even find the edges. And that's precisely where humor helps. When numbers become incomprehensible, laughter is the mental lubricant that allows us to keep thinking without our brains exploding. Because the scale of the universe is both awe-inspiring and absurdly funny if you take a step back. Imagine a human arguing over the size of their driveway while the Milky Way spins silently, 400 billion stars strong. It's cosmic comedy at its finest. Light itself complicates our understanding. The observable universe is limited by the distance light has traveled since the Big Bang, roughly 13.8 billion years. That means the furthest objects we can see emitted their light billions of years ago. We're seeing them as they were in the distant past, long before the Earth existed, before life appeared, before humans ever dreamed of looking at the stars. In effect, every observation is a peek into ancient history, a reminder that the universe is bigger not just in space but in time. And the deeper we look, the more staggering the scale becomes. Galaxies forming, merging, dying, and being born in an endless, indifferent ballet. Even concepts like the cosmic microwave background, the faint afterglow of the Big Bang, stretch the mind. This radiation fills the universe, evidence of the earliest moments of existence, and yet it is nearly uniform, whispering across the cosmos with subtle fluctuations that hint at the seeds of galaxies and structure. These fluctuations, measured in microkelvins, tell us stories of immense scale, gravity, and time, of processes that shaped everything we see today, including us. The sheer precision required to measure such tiny differences is almost laughable, considering how small and ephemeral we are. But we do it anyway, and that stubborn curiosity is humanity's unique claim to relevance in a universe that otherwise barely notices us. Then there's dark matter and dark energy. These aren't just abstract concepts. They dominate the mass energy budget of the universe, shaping its expansion, the motion of galaxies, and the ultimate fate of everything. Dark matter acts like an invisible scaffold for galaxies, providing gravitational glue where visible matter alone would fail. Dark energy pushes the cosmos apart, accelerating its expansion at rates that confound even the most sophisticated calculations. Together, they remind us that the universe is largely unseen, operating under rules we barely understand, and that everything we know, the planets, stars, humans, memes, and cat videos, is only a tiny fraction of reality. It's humbling, but also hilarious, because the universe built all of this complexity and then said, "Oh, and most of it you can't even detect yet. Good luck." Imagine, for a moment, that you're standing at the edge of a black hole. Not the fun, let's watch a sci-fi movie and pretend kind of black hole, but a real one, millions of times the mass of the sun. An object so dense that it could swallow Earth in an instant and rewrite the very fabric of reality like a cosmic editor with a permanent marker. You feel an almost electric pull, a gravitational tug that's less about being yanked and more about understanding, in some visceral way, how insignificant a single human life, or even a single planet, truly is. And as your brain struggles to wrap around this, a quiet, slightly ridiculous thought sneaks in. Maybe power isn't what we thought it was. Maybe the most powerful thing in the universe isn't even something we can punch, squeeze, or even see. Maybe it's subtle, patient, invisible, and far smarter than we are. And maybe, just maybe, it's been running the show since before we knew there was a show to run. We tend to equate power with the obvious stuff, massive explosions, armies, nuclear weapons, or hurricanes that knock your neighbor's fence over. It's tangible. You can measure it. You can complain about it over coffee. But the universe operates on scales that laugh at those definitions. Time, gravity, energy, and the fundamental forces of nature don't ask for permission, don't negotiate, and don't send invitations. They simply exist, and they rearrange everything around them while you're busy checking email or worrying about whether your houseplants are getting enough light. If the universe had a personality, it would be the kind of boss who doesn't micromanage, but just casually reshuffles entire galaxies while you wonder why your Wi-Fi is slow. Start small, in a way we can understand. Think about energy. Not the vague, I need coffee energy, but the actual physical kind that powers everything. Photons, kinetic energy, heat, the fusion reactions at the sun's core that keep life on Earth from freezing into a solid block of despair. Energy is the lifeblood of the universe. Without it, nothing happens. Stars don't shine, planets don't orbit, black holes don't lurk ominously in space. They don't exist at all. And yet, energy is invisible unless it's in motion, unless it's doing something. You can't grab a jewel in your hand, and even if you could, it would probably burn you. In that sense, energy is quietly terrifying. It is everywhere, unstoppable, and fundamentally necessary. Now take gravity. It's sneaky. It's always working, even when you forget about it. It doesn't shout, it doesn't flex, it doesn't care about your feelings. It simply binds, pulls, and bends reality itself. It forms stars, galaxies, planets, and occasionally wrecks everything spectacularly in a black hole. Gravity is patient, like the universe's passive-aggressive parent who moves pieces on the cosmic chessboard without telling anyone. Over billions of years, it sculpts the cosmos, subtly rearranging everything, from asteroid belts to galaxy clusters, with precision that humans can barely comprehend. You can fight it, sure, with a trampoline or a rocket ship, but in the grand scheme, gravity is indifferent. It's not the loudest power, but it's persistent and unavoidable, and it dictates what counts as possible anywhere in the universe. And if you think those are impressive, let's not forget time. Time is relentless. It doesn't pause for anyone, and it doesn't care about empathy or contracts. It stretches across the cosmos like a universal conveyor belt, dragging galaxies, stars, and civilizations along without consultation. Everything we consider permanent, mountains, oceans, planets, even black holes, are all temporary players on the stage of time. Over enough time, every star burns out, every planet becomes rubble, every civilization becomes dust. Time doesn't destroy to punish. It destroys because that's what exists. That kind of power isn't explosive or flashy. It's quiet, almost polite, but it wins every single round. And if you ask a human being what power feels like, time would probably nod and say, "I run everything here. You're welcome." Of course, humans are good at misunderstanding scale. We think power is about who shouts the loudest or who holds the biggest stick. But the universe doesn't recognize sticks, armies, or kingdoms. It recognizes laws. It recognizes forces. And if we start to understand the universe in its own terms, the answer to what's the most powerful thing becomes slippery, paradoxical, and slightly humbling. Because the obvious answers, energy, gravity, time, are all invisible, intangible, and terrifyingly indifferent to us. They run the show without fanfare, without applause, and without telling anyone we exist. But let's not stop there. There's also information. Not memes, not TikToks, not the fact that your neighbor knows what you had for breakfast. I mean the fundamental information that underpins reality, the way particles interact, the arrangement of quarks, the rules that govern the cosmos. Information is subtle, because it can exist without a form you can touch, see, or smell. But information shapes outcomes. Without it, there is no structure, no matter, no predictability, no universe. And the more information a system processes, the more complexity it can handle. And that, in a sense, is power. The universe itself processes information across quantum scales, across galaxies, across time. It's not doing it intentionally, of course. But if you judge power by the ability to affect change at every level simultaneously, information is absurdly potent. So far, we've talked about forces, time, energy, and information. But there's another contender that most people don't consider: entropy. Entropy is the universe's built-in chaos meter. It doesn't negotiate, it doesn't compromise, and it doesn't check your schedule. Entropy ensures that things move from order to disorder unless work is done to keep them organized. It's the reason your room eventually becomes messy, even if you're a responsible adult. Scale that up, and it's the reason stars burn out, planets age, and civilizations decline. Entropy is relentless, inevitable, and universal. It's subtle, quiet, patient, and undefeated. Humans think power is about making something happen. Entropy reminds us that the most powerful thing might be watching everything slowly unravel, unnoticed, over billions of years. Now, if you're starting to feel a little hopeless, you're supposed to. Because these powers, time, gravity, energy, entropy, are all fundamentally indifferent to our existence. They don't fight, they don't compete, they don't negotiate. And yet, they control everything. In 1,000,000 light-years away. But Virgo is part of the Ionia Chaos supercluster, a sprawling structure spanning over 500 million light-years. That's 500 million light-years. And our Milky Way? It's just a tiny component, orbiting one gravitational center among billions of stars. When you start thinking in these terms, your previous sense of big collapses entirely. Your city, your planet, your entire civilization becomes an infinitesimal speck, and the universe has the patience to wait while you struggle to make sense of it. It's almost funny how long it takes for our brains to adjust to scale. Then there's cosmic time, which stretches our understanding of history beyond anything we can truly imagine. When we look at distant galaxies, we see them as they were millions or even billions of years ago, not as they are now. The Andromeda Galaxy, our nearest large neighbor, appears as it did 2.5 million years ago. By the time its light reaches us, it's already changed, evolved, and shifted in ways we cannot witness directly. Every telescope becomes a time machine, and every image is a snapshot of a universe long gone. Humor creeps in here, too. Humans worrying about deadlines, elections, or taxes while staring at stars whose light has been traveling since before our ancestors were even human. Scale is simultaneously humbling and ridiculous. And the universe doesn't stop scaling up. Consider the concept of the cosmic web, the large-scale structure of the universe. Galaxies cluster along filaments spanning hundreds of millions of light years, creating vast voids in between where almost nothing exists. The patterns are beautiful, almost artistic, but also terrifying in their emptiness. The universe is structured, but at scales we can barely conceptualize, and even in these structures, human life is an infinitesimal blip. Our species, for all its ambition and creativity, exists for a moment in one filament of one galaxy in one cluster, floating in a void that dwarfs our imagination. And yet, here we are, building telescopes, running simulations, and trying to grasp the incomprehensible. The sheer audacity is both hilarious and inspiring. It gets stranger when we consider cosmic horizons. The observable universe is limited by the distance light has traveled since the Big Bang. There are regions beyond our observational reach, possibly infinite in number, that we cannot see and may never see. We exist in a bubble of perception, a finite island of awareness in an ocean that could be infinite. And yet, humans can imagine, calculate, and speculate about what lies beyond. We can theorize about regions, structures, and phenomena entirely inaccessible to us. The humor is subtle but undeniable. A tiny species using thought, math, and imagination to peer past the horizon of everything it can touch. Dark matter adds another layer of cosmic weirdness. This invisible substance outweighs normal matter by roughly 5 to 1, shaping galaxies, clusters, and the cosmic web. We can't see it directly, and yet we infer its existence by gravitational effects. It's like discovering a hidden framework holding a city together, and then realizing that the architects refused to provide blueprints. Humans continue to explore, measure, and theorize, stubbornly insisting that we can understand what we cannot see. It's both heroic and absurd. Then there's the possibility of multiple universes. Some cosmological models suggest that our universe is just one bubble among countless others, each with its own laws of physics, constants, and dimensions. The multiverse, if it exists, is almost too absurd to comprehend. An infinity of realities, some perhaps very much like ours, others entirely alien. And humans, tiny, fragile, and barely a blink in cosmic time, speculate about them. We build equations, run simulations, and debate probabilities, even though evidence is indirect at best. The humor in all this is hard to overstate. Species so small trying to grapple with an infinity that dwarfs imagination itself. Even within our universe, the extremes are staggering. Consider neutron stars. A teaspoon of matter from one weighs as much as a mountain. Black holes can warp space-time so violently that light itself cannot escape. Gamma-ray bursts, brief but unimaginably energetic explosions, can outshine entire galaxies in seconds. And here we are on a pale blue dot, worrying about mundane things like grocery lists and Wi-Fi passwords. Humor, in this context, becomes almost necessary. Scale is not just big, it's comically, terrifyingly, and irreducibly big. And humans continue to look, calculate, theorize, and sometimes laugh, because otherwise the mind might simply collapse under the immensity. Time complicates scale even further. The universe is 13.8 billion years old, but that number is almost meaningless without context. Stars live millions to billions of years. Galaxies evolve over billions. Black holes endure for periods that make human history look like a hiccup. And yet humans, with lifespans measured in decades, are capable of understanding, modeling, and predicting phenomena on time scales millions of times longer than our existence. It's both awe-inspiring and absurd, and it invites humor. A species blink and you miss it old trying to comprehend what persists almost infinitely. Finally, there's perspective. From a human vantage point, the universe is vast, indifferent, and full of wonders. And yet, we exist, we perceive, we calculate, and we laugh. We build probes to explore the solar system, telescopes to see distant galaxies, and equations to model phenomena that will outlast every civilization that has ever existed. Our lives are brief, our planet tiny, and our cosmic importance negligible, but our curiosity persists. That persistence is absurd, brave, and uniquely human. The universe, infinite or not, doesn't care, and that makes our attempts to comprehend it both heroic and comical. If you followed along, marveling at incomprehensible distances, laughing at the audacity of a species this small studying something this vast, consider subscribing to keep exploring. The universe is infinite, or maybe it isn't. But either way, it's far bigger than our intuition, far stranger than our imagination, and far more absurdly funny than we often realize. And the next discoveries, images, and theories? They're waiting billions of light years away to remind us how big, weird, and wonderful reality really is. By now, if you're still with me, you're starting to realize just how laughably small we are. And yet, the universe keeps stretching. The observable cosmos, as we've seen, spans about 93 billion light years, but there's a strong possibility that what we see is only a tiny fraction of the whole. Beyond the cosmic horizon, galaxies, clusters, and structures may extend infinitely. In that case, everything we can measure, every star, every planet, every human drama unfolding on Earth, is just a speck on a canvas so vast that it would make a trillion Earths look like freckles. And yet here we are, building telescopes, running simulations, and calculating probabilities as though our little minds can somehow grasp infinity. Humor sneaks in, because it's almost laughably ambitious and deeply human. Cosmic inflation adds another layer of strangeness. In the earliest moments of the universe, it expanded exponentially, faster than light itself, stretching space to unimaginable scales. The regions we can observe are tiny patches in an enormous, probably infinite, expanse. That means stars we see today are like dots in a vast mural whose edges we may never reach or even perceive. Inflation also predicts that other pocket universes could exist, each with different physical laws. Some might have no matter, no light, or no time as we understand it, and humans, tiny, fragile, and absurdly curious, speculate about these regions, develop equations, and theorize about realities we may never touch. The audacity and subtle humor of trying to imagine a completely alien universe while arguing about which planet should be colonized first is quintessentially human. Then comes the ultimate cosmic punchline, the fate of the universe. Dark energy drives accelerated expansion, ensuring that galaxies not gravitationally bound to our local group will eventually recede faster than light, disappearing forever from view. Stars will burn out, galaxies will collide and merge, and the universe will approach a cold, dark, diffuse state. This heat-death scenario is unimaginably slow, spanning trillions of years, but the scale is staggering. Humanity, even if we survive for millennia, is a blink in this process. And yet, here we are trying to understand it, joke about it, and sometimes even philosophize over it. The universe's indifference is vast, and our curiosity, tiny, stubborn, and irrepressibly ambitious, persists anyway. It's humbling, but also oddly reassuring. Humor helps. Imagine generations of humans pondering the fate of stars billions of years in the future, while trying to figure out why someone left the milk out in the fridge. The absurdity isn't a flaw, it's a survival strategy. Humor allows us to maintain perspective, to acknowledge the incomprehensible vastness of reality without succumbing to despair. Laughter, like curiosity, is part of our toolkit for engaging with the infinite. It's how humans persist in a universe that is far larger, older, and stranger than we could ever hope to control. We can also contemplate extreme distances in terms of human perception. Light from the cosmic microwave background, the afterglow of the Big Bang, has traveled 13.8 billion years to reach us. That light carries information about the universe when it was a fraction of its current age. It's a literal message from the ancient past, whispering secrets of creation across time and space. And humans decode it, translate it into maps, equations, and animations, and then share it with others who, in most cases, are still figuring out the difference between a light year and a pizza delivery mile. The audacity is hilarious, but it's also profoundly human, a species so small attempting to understand the enormity of existence. And then, the mind-bending notion of the multiverse enters the conversation. If inflation theory is correct, there could be an infinite number of universes, each with its own physics, dimensions, and structure. Some may resemble ours, with stars, galaxies, and planets. Others may be entirely alien, with no concept of time, matter, or life as we know it. Humans, equipped with curiosity, equations, and humor, try to imagine these possibilities. Some of the speculations border on science fiction, yet they are anchored in real theory, evidence, and the stubborn drive to understand. It's a mix of philosophy, physics, and absurd optimism that only humans could produce. Distance, scale, and time also challenge our psychological framework. The numbers involved are so large that our brains struggle to conceptualize them. A single galaxy cluster might span hundreds of millions of light years, but the observable universe contains trillions of galaxies. Our solar system, Earth, and even our Milky Way are tiny islands in a vast cosmic ocean. And yet, humans find ways to explore, measure, and model. We send probes, build telescopes, and run simulations, proof that even infinitesimal beings can reach for comprehension. Humor softens the cognitive blow, reminding us that our attempts are as delightful as they are absurd. The universe also challenges our understanding of significance. On one hand, humans are ephemeral. Civilizations rise and fall, stars live and die, and galaxies collide silently over billions of years. On the other hand, humans are remarkable in their curiosity, ingenuity, and creativity. We measure, observe, and imagine things vastly larger than ourselves. We look at a speck of light billions of light years away and attempt to understand its history, composition, and trajectory. That duality, insignificant yet capable of profound insight, is both humbling and humorous. The universe may be indifferent, but we persist in making sense of it, laughing along the way. Speculation about the ultimate scale brings even more philosophical questions. If the universe is infinite, what does that imply about repetition and probability? Somewhere, infinitely far away, could there be another Earth, another you, reading the same words right now? Could civilizations like ours exist in countless variations, some exploring galaxies while others are stuck in caves or labs? And if the universe is finite but unbounded, could it curve back on itself, creating loops, echoes, or patterns we cannot perceive? These thoughts are almost comedic in their scope, humans attempting to model infinity with finite minds. And yet, our curiosity persists. Despite all these extremes, humans continue to explore, map, and learn. The Hubble Space Telescope, James Webb Space Telescope, and other instruments reveal galaxies forming, dying, and colliding across billions of years. They provide glimpses into processes that shaped the universe long before our species existed. And even as we decode these images, equations, and models, we do so with humor, acknowledging our tiny, fragile, and absurdly bold position in the cosmos. We are observers, explorers, and interpreters, tiny beings navigating a universe so vast that even big becomes meaningless. The scale also forces perspective on life and existence. The Earth is tiny, yet it is home. Humanity is fleeting, yet we are capable of insight, creativity, and wonder. We are simultaneously insignificant and extraordinary, a combination that inspires awe, humility, and laughter. Understanding the size of the universe reminds us that our problems, fears, and triumphs occur within a vast context far beyond our immediate perception. Humor allows us to navigate that realization without despair, while curiosity drives us to continue exploring. Ultimately, the question of how big the universe is becomes more than a scientific one. It's a philosophical, existential, and even comedic question. The universe is vast, mostly invisible, and fundamentally indifferent. Humans are tiny, ephemeral, and fragile. Yet we observe, measure, calculate, and laugh. Our curiosity propels us toward understanding, even when comprehension seems impossible. We build telescopes, run simulations, and explore theories, all while joking about our own limitations. That, perhaps, is the most remarkable thing of all. In a universe this large, tiny humans persist, strive, and even find humor in their audacity. So, if you've marveled at galaxies, chuckled at cosmic absurdity, and wondered about the infinite, consider subscribing to keep exploring. The universe is far bigger than our intuition, stranger than our imagination, and funnier than we sometimes realize. And while the cosmos expands, evolves, and hums along indifferent to our existence, humans continue to observe, calculate, imagine, and laugh. And that persistence, that stubborn, absurd, hilarious persistence,